was so funny?
I don't know. I got like a tickle in my throat, and I couldn't.
I was just loving the enthusiasm. That's all.
Welcome to GCP Life, episode number 20. GCP Life is a podcast where we discuss Google Cloud and tech. This show is sponsored by Kasna. At Kasna, we make your Google Cloud solutions possible. Now, I'm your host, Stephen Bancroft. On today's show, we break format with a deep dive into GCVE, Google Cloud's VMware Engine service. Plus, we hear a few new horror stories. But before we get to any of that, I want to introduce the co-host that's with me all the time, Dave Wall. How are you going, Dave?
I am doing absolutely brilliantly. Thanks, Banky. How are you today?
I am awesome, and we have a special guest with us today, Ian Brown. How are you going, Ian?
Oh, I'm fantastic. How are you doing, guys?
Good, guys. A little more upbeat, guys. A little more vibe. I want some more vibe. A bit more mojo.
Glad to have company on this one today.
Yeah.
I know. It's going to be great. Yes, we are here today. We're breaking format. We're going into GCVE deep dive. The three of us just came off a really, really exciting, really fun project, which was a GCVE migration, moving a whole bunch of stuff from on-prem VMware estate into GCVE in Google Cloud. How would you sum it up in a sentence?
Rapid?
Rapid?
Moved a lot of gear in a short period of time.
Rapid learning curve was another one. Yeah, it was.
Yeah. And we'll get into all the details on that as we move through, but we do have a special guest here for this episode, Ian. Now, as is tradition, Ian, first of all, introduce yourself, and as is tradition on the show, we like to hear a horror story from you. I mean, you've been working in tech for quite a while. I'm sure you've got a few horror stories.
Oh, I've got a few indeed. Obviously, I'm Ian. I'm a senior cloud engineer with Kasna. I'm also a Google developers expert specializing in cloud platform, and I've been in IT for 24 years, something around that long. It's been a while. But let's go with a horror story, hey?
Yeah. Oh, I'll tell you what. I'll just because I never get a chance to tell horror stories. I got tons of them, right? So I'll just kick one. I'll just kick it off just to break the ice a little bit. It's a quick one, right? I worked with a bloke that deleted /bin because he thought it was a rubbish bin directory.
Oh, that was good. Just empty the trash.
Empty the trash.
Well,
yeah. Anyway,
well, clearly we don't need those things. They're in the bin.
Well, mine was a typo. I was a young fella working for a very large real estate company in Australia, looking after their web platform, and I meant to delete the current directory that I was in. So, as all Unix admins do, rm-rf ... except I missed the dot. On a production server, not too bad. We had another one. So that was the worst one that I did.
You got to be careful with RM-RF wherever you are. Yep.
Yeah, definitely. And then here we go. Here's a classic one. I had some help one day, and we use the term help in inverted commas. I was at a small builders in Brisbane, and they were having issues with one of the disks in the server. It started flashing orange, so bloke in the office called me. I said, I just pull it out and put it back in. Let me know what it is. Take a photo of it and send it to me, and I'll order a new one. And so he did that, and the disk came green again. So we didn't worry about it for a little bit. I've already ordered the new one. And then it started flashing again. So he thought he'll take it upon himself. He'll pull it out, and he'll swap it with one of the other disks in the RAID 5. And, of course, we lost the RAID.
Ouch.
That took about 3 weeks to get back, and a lot of money.
Yeah.
Right, so backups, or you went to a specialist recovery service?
Specialist recovery service.
Yeah. Yep. And they did the full forensics on the drive to get everything off it. Ouch.
Yep. Yeah, that one hurt.
Yeah.
Back to your previous one on the old RM-RF. You think that we could engineer around that, right? Like have a little safety break that if you ever do like, say, a sudo RM minus RF slash, then it should come and go, hey, do you really want to do this? This one command has broken so many systems.
Yeah, well, what you really should do is alias RM to RM minus I, so it does it interactively and actually prompts you.
Yep. So what we did was actually alias the entire command. So if someone tried to do that again, all it did was respond back with a sorry, not doing that.
Yeah.
Yeah. Yeah, there's certain safeties around it. Yeah, I've seen tricks with using find and stuff when you're doing that, so you don't, accidentally delete the root directory. Yeah, you just got to be careful. I personally haven't done it. Been close though, I'd have to say. Been close.
I learned very quickly to pay a lot more attention to what I was doing than just keying in the commands, because it was obviously over a SSH and the link was a bit laggy, so it missed the dot and it got the slash instead.
Yep. Oh, ouch. All right, well, look, guys, just before we get into everything, have you guys been up to any tech adventures during the week? I know I finally built my new rig.
Spill the tea.
I've built it, yeah. So we've ended up with the B550 motherboard with a Ryzen 5700 through that old 3070 Ti in there. And in War Thunder, I can get about 189 frames per second in War Thunder. That's on full high quality mode.
Yep.
But the CPU is absolutely clapped out to do that. And there's no headroom at all. So I've actually backed it down to 90 frames per second, and it is like butter.
Yeah,
it is so smooth. Solid 90, no jerking, no flicks or anything like that, no tearing, and there's a bit of headroom in there, for it to go up and down if there's any background processes going on. But yeah, very happy with the build. I've got some of these new Noctua fans, put them in there, 4-pin PWM
the classy
fans.
brown ones?
The classy brown ones, they're the ones. Because the Dagyell case fans that were in there were just, they had the old knob on them, that kind of style.
Yeah.
Because I did repurpose the case, and it is quiet. It is so quiet now. The little NAS sitting on the table behind me is louder than it. So you're very, very happy with the way that's come out. And, I ended up, originally I didn't plan to put spinning discs in there. I was just going to go with
all flash,
rated all flash, but I had 2 4TB discs, so I just rated them up, and now I've got just like an 8TB, or I just install all Steam stuff and all that. And mate, it is quick. The discs hum along quite nicely, and games load a lot quicker, and I'm getting my work done a lot faster.
Oh, good.
Great.
And your old machine, have you got a Destiny for it?
Yeah, so it's a Sabertooth X58, which is an awesome motherboard for the era. And I actually have a Intel 990X, which is the Intel Extreme CPU, 12-core Extreme, which is the biggest CPU that will go on that motherboard, and it's maxed out, 24 gig of RAM. But yeah, that'll get used. I'm going to use that as a Proxmox machine.
Oh, yeah, I think that might just hit the minimum specs required.
Yeah. Well, I put Proxmox on a lot of old stuff, and it does work. So yeah, I'll just have some containers and virtual machines on there and muck around with them. That'll go into my data center space under the house.
Oh, very nice. I was also repurposing some kit. So I think I mentioned a while ago that I was playing around with OpenSense I was going to virtualize the firewall. And finally forced my hand on it on Friday because I got my NBN upgraded, and which is great. So loving being able to get a gig down. That's awesome. Unfortunately, my old router just couldn't push it. My router with a VPN tunnel and any IPS or IDS turned on, I could only get 170 meg through it. It just couldn't handle it. So yeah, I had an old QNAP NAS sitting around. I'm like, maybe I'm better off doing that rather than virtualizing it and running on my TrueNAS box. I kind of like the idea of keeping my firewall as a separate physical thing. So if I'm away and I need someone to reboot it, they can. They don't have to try and log into, my virtual appliance and do it that way. So, I looked up how to reinstall the OS on one of those. And in the end, all I had to do was take the chassis off it, and then there's a little DOM that's inside that just sits on like an 8-pin header, and just pop that off, put a fresh disk in it, and then it just boots up, and I was able to install OpenSense on there fine. So
easy peasy, yeah.
Nice.
Yeah. The only thing that I haven't worked out how to do is it's got a screen on it, which normally on your QNAP app would tell you like the IP address of the box, and now the screen comes up, but it just consistently says like booting up. Just all the time. It's got booting up on a little progress bar that just keeps moving across. So I've got to find like a free BSD plugin that can interact with it.
What about yourself, Ian?
Oh, mate, I've speaking about gaming. I got alerted the other day. I'm part of a group called Flounder, which is a free and open source software down under, and we got alerted the other day to a pure Linux gaming environment called Empty Epsilon, which is a sort of a clone of Artemis Spaceship Bridge. So I just downloaded that last night onto my little laptop that sits off the side here, an old Fedora box, and it just hums along quite nicely. So I'll give that a bit more of a go and report back later.
Yeah, right. I'm just having a look here. Empty Epsilon.
That's it. Yeah.
Like Artemis Spaceship Bridge Simulator.
Yep.
Yeah, right. I'll chuck a link in the show notes for that one.
Yeah, that's a really cool project. And on a more technical one, I've been playing with the Raspberry Pi Pico, and I've got a little temperature sensor that sits in my office here that I've coded up using Python with a little LCD screen. And now I'm feeding that data back into Google Cloud's IoT.
Oh, awesome.
So,
very cool, yeah.
So I'm going to do a write-up on that on my blog in the coming weeks.
And you got any long-term aspirations for this device?
Oh, not for the temperature sensor. It was just more of a little play around for me to learn how to punch stuff into IoT Core.
Sure.
But yeah, there is a side project going on for me that's got to do with cattle and farming and the likes, and LoRa.
Yeah. Because, you're in Queensland, so that's kind of what Queensland's all about, right?
We don't like to, treat servers as pets anymore. So, we're treating servers as cattle, and I guess cattle as cattle, right?
That's exactly right.
All right, guys, let's go on with the show. Look, we are going to get into GCVE stuff, but I thought there'd be a couple of Stop the Presses stories. And I thought we'd cover this one now. Look, at first I saw this story and I thought, it's a bit nothing. But then I thought, let's talk about it. Google Cloud introduces optimized Rocky Linux images for customers moving off CentOS. Google Cloud builds and supports Rocky Linux images for compute image with both a fully open source version and one optimized for Google Cloud. So that's good. The fact we're still getting a Google Cloud optimized image.
I mean, I suppose this one would be more as a competitor to Amazon Linux, which is their CentOS distribution, or CentOS kind of based.
Right.
That's where I would see this. Like, you still want CentOS, you don't want to cut across to a Debian-based system, then you can go with Rocky Linux.
Well, that's what I thought as well, because you're not going to go down the RHEL path, right? If you're just some little project, but you want Red Hat.
You really like Yum, so
and you really like Yum, yeah.
Well, I see it as. I don't actually see it as a Red Hat problem there, because to my knowledge, Rocky Linux isn't actually a Red Hat product. StreamOS is the replacement for CentOS.
That's right. It's not a Red Hat product. It's just been spun up by randos.
Yeah. So it's the original founder of CentOS has spun this up as the replacement to CentOS. Now that Red Hat owns CentOS, and I think it's probably a good thing that Google is doing this, because lots of people use CentOS and they need something to migrate to, and Stream really isn't it. And
yeah, exactly. That's the point I was trying to make. Yeah, it needs to be something in that space.
Yep. And I don't really want to pay Red Hat licenses for RHEL, because that's crazy.
Why would you if you're like a little small project, or you don't need the enterprise features, then why would you? Yeah, so interesting one there to make note of. Don't build anything on CentOS if you're using the Red Hat environment. Stick with Rocky Linux. Now, one that's a little more close to what we're going to be discussing today, and this is really interesting, load balancing Google Cloud VMware Engine with Traffic Director.
Yeah, this is very cool. This is something that we've done. Well, not this particular way of doing things, but we did so much work with load balancers on GCVE, and finding new solutions to be able to enhance that product is awesome.
Yeah, so what we're able to do now is we're able to use Google Cloud load balancing front end with Envoy proxy and put the entirety of GCVE behind that. And get all the advantages that you would get with the Google Cloud load balancing front end. So I guess global IPs, DDoS protection,
certificate management,
certificate management. Boy, yeah,
that's like my favorite thing.
and bring your own IP.
And bring your own IP. Yeah. Now the question I proposed to you guys during the week is, and I'm still not able to find out an answer to this. I was looking this morning. How many IPs can you put on this cloud load balancing front end? Because we know that with traditionally up to now, there's been a limit of eight IPs you can put on it. And we know the project we just did, how many IPs do they have? 60 odd, 70? Yeah.
Yeah, I mean, this is one that I think we definitely would need to play around with. Maybe Traffic Director would help obfuscate some of that complexity.
Yeah.
Because if it's going to do the provisioning for you and manage the workflow, then it sort of doesn't really matter. If you've got 8, then it'll just have to spin up another one.
So it's not really clear to me how the traffic director and Envoy fits in there. Is that being spun up as a separate resource that sort of integrates with load balancer, like, say, a managed instance group would be?
Yeah, I think that the Envoy proxies are behind the cloud load balancer, and then they manage the traffic flow back to NSX. Whether or not you're sending it straight to your VMs in NSX, your GCVE VMs, which happen to run inside of NSX, or if you would back it with a layer 4 or layer 7 load balancer inside.
Yeah. So you can do either models. You can go directly to your workloads or via another layer of load balancing, which in this blog they point out is beneficial if you have internal access requirements. So the access from the load balancer or the access from internal looks the same because you're hitting that NSX load balancer.
Yeah, and then you get the really awesome thing is if you were in the middle of say a cloud transformation strategy, you might have migrated into GCVE, but you're now going to start modernizing your workloads. Well, then you could move some of your workloads out, and you just would change, within Traffic Director, some of those backings. So you could still have, you could be backing that load balancer into GCVE, but also maybe, one of your pools is now in Compute Engine or in GKE or something else.
Yep. Yeah, that's where I see this really coming into its own, is that modernization effort. Right.
It can act as a big ka-chunk switch, so to speak.
Yeah.
Yeah, especially if you were thinking of, say, like changing IPs as part of, say, your migration to GCVE. If you did that instead of doing BYOP, then by sitting everything in front of your cloud load balancer, then you only have to make that change once. Because you've done it now, and then all your other change as you modernize is all internal networking.
Yeah. Once you set that front end up, that's it. It's there for perpetuity. Yeah. Anyway, great little blog there. I'll link that in the show notes. And it also has a bunch of links off to some really good resources for documentation on Traffic Director and hybrid networking and exactly how the HTTPS load balancers work. So that's a good resource if you're setting up something like this. All right, well, they were a couple of Stop the Presses stories that we came across during the week. Look, there's tons of stories every week, but really we need to save some space in the show this week to get on with our GCVE conversation.
Is that what we're here for?
That's what we're here for today. I thought I'd kick things off with sort of an intro, a little overview of what GCVE is. GCVE, it's Google Cloud VMware Engine, obviously. It's given GCP customers the ability to deploy cloud apps on a certified VMware stack that's managed and supported and maintained by Google. That's really the crux of it. They take all of that heavy lifting of looking after that entire estate of, switches and servers and the whole rest of it, and they're doing the whole lot for you. Makes it easy to lift and shift your VMware-based applications to Google Cloud without changes to your apps, tools, or processes. Well, we'll get into that later. Yes and no. Includes all the hardware and VMware licenses, which is great. It's all bundled in one fee to run dedicated VMware SDDCs in Google Cloud. A couple of key features. It's fully integrated VMware experience. So if you're used to running VMware on-prem and using vCenter, then you're going to get exactly the same experience when you use vCenter in Google Cloud. Fast provisioning. There's auto-scaling, and we'll talk about auto-scaling a little more deeply as we move through. But you don't need to say how many nodes up front you want. You could just set up 3 nodes, and then when some load comes in or you need some extra space, it'll scale out or scale down depending on the demand. Use familiar third-party apps. You can continue to use database storage, disaster recovery, and backup solutions. And Tifico is a perfect example of that, and Ian will give us a little talk about that as we move through. A couple of key points about it. It's on-demand self-service provisioning. It's just if you need another private cloud, it's very easy in the GUI just to click and create a new private cloud, and then you've got another self-contained estate of VMware servers. It has integrated connectivity with Google Cloud services, so you have high-speed throughput for all the Google Cloud APIs. If you want to use this as a stepping stone to move from on-prem into a modernized infrastructure, then that's a perfect use case. You can go into GCVE, and then you just sort of take that strangler pattern and pull everything apart and start consuming cloud services. It provides performant networking, 100 gig redundant links from all the nodes.
Yeah, and I think that it's so cool. I mean, very few data centers now are still at that level. I think you get it's split up 50-50 between data traffic and storage traffic, but it's still those are big links, and then your internet connections are sitting behind Google's internet services.
Yeah, absolutely. The speed is phenomenal. I mean, it's in a lot of cases, it feels instantaneous sometimes, depending on the size of what you're doing. But the speed knocks you out of your chair. And of course, the whole thing's simplified. You don't have to get your hands dirty with a lot of the management of VMware and GCVE, VMware itself. Google looks after all that.
I think
that's very easy.
I think that's the best part about it, to be honest. I mean, we've all been around the IT industry for donkey's years, and we all remember getting new nodes in and building ourselves in the latest version of VMware, and the days and weeks of effort it'd take to do it and then merge everything over onto it. And this is just, it's just there. I need new.
It's just there.
Yeah, I don't have to plan for my final number of nodes. I plan for what I need right now, and then I add them if I need them.
Add them as you go.
And get rid of them as you need them. Right? And it's something that I'm... I know has happened recently, right, is we need to copy a really large VM. It's going to take up twice the amount of storage. Okay, I'll spin up 2 extra nodes, clone the VM, finish what I'm doing with it, get rid of the clone, get rid of the 2 nodes. Good luck doing that on-prem. Like, I've just got to go buy, $250,000 worth of hardware for an afternoon and then get rid of it.
And sell it on eBay later.
Yeah. Another 2 pizza boxes and off we go.
Although I do miss unpacking those boxes. That was always fun.
I actually kind of miss when you decommission something, you're like, oh, it's got a lot of RAM in it. I can still use that.
Yeah, I don't know what I like better, unpacking the box or turning the old box off. That was always satisfying.
It is satisfying to decommissioning something.
Yeah,
especially when that
absolutely.
thing's been a pain.
Yeah.
Oh, yeah.
Power button. We've all had that one server that just constantly has
cursed server.
Yeah. But the thing I don't miss, honestly, is being in a data center for hours and hours on end. That screaming of fans that are in your ears constantly.
Yeah.
You don't have
dehydration.
You don't have to deal with any of it. Nope.
And I think we were talking about turning up the VMware environment, but GCVE is not just spinning up an ESX high host, right? It really is like spinning up a separate data center. It's got its own constructs in it that are like separate firewalls and separate internet access. It has the capability to be like a small VPN service so that your engineers can VPN directly into them. There's a lot to it. It's really flexible.
Yeah.
Yeah, so while you're at it, Dave, why don't you tell us about the maintenance side of things on GCVE?
So the maintenance side of things, both like patching and hardware maintenance, this is I suppose one of my favorite things with it because, I've managed large clusters, and especially if you've ever had to manage a vSAN cluster, because it's not just updating the version of ESXi that's on the box, especially with vSAN, you really need to make sure that your firmware through the entire stack is validated. And as things get updated, I have seen this, not in one of my clusters, but one that I'm aware of in a previous employer, where there was a firmware update that was required for an SSD that the team hadn't been informed of by the vendor, who will remain nameless, that caused a data loss event. Right? Now, having to manage that yourself is a real burden. You're an engineering team, you've got your own priorities, and all of a sudden, a CVE comes out and you go, oh, okay, throw off what we're doing, guys. We've got a plan to patch this week because there's a 9+ CVE out there. And then you're getting into, I said, on the vSAN side of things, making sure you got your firmware validated. It's a pain. And
a lot of the time, Google are taking the updates before they're even announced, aren't they?
And that's 100% correct, right? So I know that's happened in the last year. I think that's happened at least once. So it might actually be twice now. That Google has patched the entire fleet of GCVE worldwide before the announcement of the articles out. So
phenomenal.
It's a whole another league, right?
And that's part and parcel of it being a first party service too. It is so tightly integrated into Google that it's not like other vendors, we'll say, where you've got to go to VMware to get your patches and all that sort of stuff. It's straight from Google.
Straight from Google.
Yep. Single point of call.
Yep. You don't have to call VMware for any support issues. You talk to Google. If they need to escalate to VMware, they will. But they can do it all with their own team. So, as I was mentioning, the patching of vCenter, your ESXi host, NSXT, that is completely managed by Google. Right, they are responsible for all of that lifecycle management, including the vCenter PSC as well. The only thing that they don't do is if you've got other things that are installed in there. So if you've got SRM or VROPS or anything like that, those still sit in your scope. And for critical security patches, they patch within the week. Right, so that's the SLA for their that management. And just not having to deal with that yourself, it really is brilliant. And in terms of how they actually manage the patches, so say you've got a cluster that is 10 nodes, right? That's what you're paying for. You've got 10 nodes. If they need to patch, they'll add an 11th node, right? And then they'll go through and maintain. So during the maintenance window, you've still got everything that you wanted. You don't have to provision an extra node just to handle for a maintenance event. Same goes for if there's a hardware failure, because these are servers and things die. We had a case where there was a DIMM failed in one node.
That's right.
Yeah.
They just connect a new node, drain the old node, and that node never comes back for you. It gets fixed.
Yep.
And
then it goes back into their available pool once they sort it out.
Yeah, so I love that. There's no waiting for an outage window, like, okay, we're going to the DC, we're going to drop a few things down, or, maybe we're a little bit oversubscribed here, so we have to shut off a couple of dev workloads to handle taking a host down. No, there's none of that.
No.
And the other cool thing is if you're using like affinity groups, so say you've got SQL pinning in the environment, you're really trying to keep some VMs on some certain hosts, it takes that into account. So it can replace a host in the affinity group.
Ah, right, because that's a question we had early on, wasn't it?
Yeah, because that's a common thing, right? You don't want to have SQL Enterprise licensing on your entire cluster, for example. So I want all my SQL Enterprise stuff on, 3 hosts. And so, it takes that into account. It's really cool.
Yeah, cool. And talking about auto-scaling, I think, Ian, you had a little bit to say on auto-scaling, didn't you?
Yeah, definitely. So speaking of the patching where Google adds a node in, obviously you get that node for nothing whilst they're patching the cluster, and then they get rid of it afterwards. But auto-scaling is really cool. We've always been in a situation in traditional VMware where you have to predict how big your cluster has to be, whether that's an essentials license or whether it's enterprise, and you've got 10 nodes in your cluster. You've got to sort of, on-prem, you've got to pick it pretty accurately. In Google, you don't. If you start out with 3 nodes as a standard cluster for vSAN, and as you put workloads into that cluster, if you've got auto-scaling turned on, then the cluster scales automatically. So it'll add a node when it needs to, when your vSAN gets to a threshold, and it can remove it as well when it gets to a different threshold. And the thresholds are pretty simple. So the ones that come out of the box are storage capacity. So if your vSAN is more than 75% consumed, you'll go up a node. And conversely, if it's less than 40% consumed, it'll go down a node. Then you've got CPU performance. So everything takes into account the storage. It just adds the CPU or memory, or CPU and memory onto it. So CPU utilization above 70%, it'll go up and if your storage is also more than 75%, or if your storage is more than 75%, it'll go up. And if it'll go down if CPU utilization is below 45% and the storage is under 40%. Now, notice there's a difference there. If you're adding a node, it's an either-or scenario. If you're removing a node, it's an and scenario. So all the metrics have to be true, or all the tests have to be true in order to remove one, versus if you're scaling up, any of the metrics have to be true.
And what about setting limits on auto-scaling? Does this just keep growing forever, or...?
Well, look, you can leave it grow forever. There is an ability to set a limit inside the console, which is really cool. We did that in the last project. We set the limit at 10, I think, initially, and then we bumped it up to 16, I think was the final number we ended up at. Maybe it was 14. I can't quite remember. But yeah, there is definitely a limit there. It's much the same as auto-scaling in Kubernetes. If you've ever used Kubernetes or GKE, you can see there's an auto-scaling there for the node pool. This is exactly the same. It just adds VMware nodes.
Real tin.
Yeah, exactly right. Real tin. It's actually proper. It is Dell hardware. It's Dell PowerEdge servers. The time to scale is a really cool one. It's about 45 minutes to add an entire node in and have it online. General experience is it's somewhere between 45 minutes and an hour to have a machine fully online and in the pool. And that's just rebalance vSAN as well.
Yeah, I think that's the key thing, right? It really depends how busy your vSAN is to actually get that data striped across it. So,
yeah, that's right.
Given that you've got 50 gig a millisecond of bandwidth there.
Yeah. We did notice, and this is one of the things that I found really, really awesome with the product. we noticed because we had two private clouds, the monitoring wasn't actually checking the CPU RAM and vSAN usage correctly per private cloud. And we'd raised this with Google, and they fixed it. And I think it was a week or two before they fixed it, but they fixed it so that auto scaling actually worked. So that was really good to have Google on top of it straight away.
Yeah, and that was like their product teams actually updating. It was really cool. I think it was we had an extra data store connected, and so it was seeing that it was that particular one was like not constrained, not just the vSAN one. So yeah, but it was really nice to actually see, them being just so receptive to that.
Yeah,
getting things fixed.
Yeah, well, I think that's about it for auto scaling. It's a really cool feature.
I mean, I just love that. Like, obviously, being able to grow it is great, but definitely also being able to shrink it, especially if you're on that. I said that transformation journey where I'm in GCVE now, and that's got me off prem, and that's great. But now, as I'm starting to completely modernize my application stack, well, I can start shrinking things down. Maybe I can, depending on your environment, maybe you're CPU constrained. So you might start looking at, all right, what's my heavy hitter CPU nodes to get out of there? Or maybe like you've got some just really big database servers. It's like, if I get rid of these 2 DBs, I might be able to like half my fleet.
Yeah, that's right. And we saw that too. We saw that big databases. You get rid of them into Cloud SQL, and all of a sudden you can get rid of a node or 2 nodes.
Your demand on your private cloud drops dramatically once you get rid of those databases. Yeah, absolutely.
And the demand on your back pocket does the same.
For sure.
That's right.
I think it's something.
And it's another managed service, right? So you don't have to faff around with it. Yeah.
Right. And there is also, because you're in Google already, like once you're in here, all your data is there. You're able to consume things outside of the GCVE side. You're plumbed in, right? And one of those that you can use is like NetApp Cloud Volumes. So you can present storage from outside of GCVE. You can have a cloud volume in GCP, and you can present that as an NFS mount straight to your VMs.
Yep. Yeah, and that's a really good and cheap way of getting extra storage if you need to, without just spinning up another node.
Yep. And speaking of integration, it's really tightly integrated with monitoring, with Google Cloud Monitoring. We touched on monitoring a little bit earlier, and I want to talk about this because if you go and look in the Terraform module registry, you'll find a module by yours truly which actually spins up the entire GCVE monitoring agent for you. It makes things easy. If you were to follow the Google instructions, you got to follow the bouncing ball, and it can get quite confusing at times. But this module does it all for you. I'll put a link in the show notes. And what it enables you to do then is collect the logging and monitoring from the VMware cloud, from the VMware nodes, and integrate that into a logging project. If you spin up a separate logging project, and there are some dashboards that you can use. So it helps you gain visibility in performance, availability, and health of your applications and infrastructure. You can use Google Cloud Monitoring as parts of Google's Cloud's operations suite to monitor, troubleshoot, and operate VMware Engine services at scale. So once you've done that, you can then build up a couple of dashboards, and those dashboards give you. There's 3 main dashboards that are available. One is an overview dashboard, which gives you a high-level view that lists key resources, data centers, clusters, and VMs. Really handy. The contention dashboard, resource utilization for storage, CPU, memory, networking, to help you locate top VMs and hosts by resource demand. You also get the virtual machine performance dashboard. This dashboard drills down into the actual VMs, the virtual machine instant performance indicators that can be filtered by instance name and used to compare the performance of multiple VMs with each other. Now, one really, really cool thing that we did with this, and I'm going to talk about NSX shortly, but using what came out of GCVE logging, when we did our migration, we were actually able to build out custom dashboards for the firewall logs.
Yeah, using log-based metrics.
using log-based metrics, which is already baked into cloud operations. And doing that, we were able to immediately tell where there was a problem when an app migrated. We could see what ports, what network blocks were in place, and we could just jump on it straight away and fix it.
Yeah, that's a little bit of regex goes a long way.
A little bit of regex goes a long way, but that was a game changer.
So much. Having that all just in a dashboard, and all of a sudden I could see, all right, we just moved some workloads, and there's all just brand new things that are being blocked.
Straight away, something pops in there. We go, we've got a problem here straight away. We could tell.
And then the flip side of that is putting the on-premise firewall logs in as well. Because that gave us the insight in this last migration of when we were trying to hit on-premise workloads and the firewall on-prem was blocking us. And it was amazing to be able to do that because the changes, it takes us 2 minutes to change a firewall rule using Terraform.
That's right. But quite often it's finding the problem that takes the time, right? It's not the actual implementation, it's finding it. And of course, being cloud operations, you can feed your on-prem logs from any device straight into there, and then you can just parse it and create sort of any metric you like from that, which is exactly what we did. And having them all integrated in one single place, game changer.
Yeah, no clicking around, I got to log into the firewall and see what's being hit now. And even the native NSXT interface for seeing what traffic's hitting firewalls isn't great. Right, no. Like they're assuming that you're using something like Login Site or Splunk or Cloud Operations. Right, so that's where you have to go to pull that data out. Yep,
for sure. Monitoring is well looked after. I guess the way we ended up setting it up is we did end up with a separate monitoring project, and that's really good as well because you could get people that aren't operations people, part of an observability team or SRE team that need to go in and find these problems, and they can have independent access and do what they like in there to create whatever views they need.
Yeah. I think the other thing that we were able to do then was because all those logs were hitting there, we also had like login events and auditing events. So, we were able to build out an alert for, if someone logs in with the Break Glass admin account. Yeah. We want everyone to know about that.
Yeah, that's right. Because that's the one that really shouldn't be used unless something really bad has happened because it's the full user, the full root account.
Oh, yeah. Look, logging and monitoring is a bottomless pit, really. Yep. But you do need to be. You can get distracted with it, and you do need to be careful that you set up what's important to view and monitor and be alerted by. Otherwise, there's just too much noise. They tend to get ignored. But it's really good for these guys. The project we just came off because they really didn't have anything in place like that at all. And just out of the box, so we just built this. We were just able to create this for them, and now they've got it. So one other technology that we did implement for them is NSXT. Now, what is NSXT? Well, VMware NSX is a network virtualization and security platform that enables the virtual cloud network. So it's basically software-defined networking within VMware. You can reproduce your entire network in software, the entire topology, from simple stuff to more complex multi-tier stuff. It can be provisioned in seconds, and it is really fast. We'll get into how that works shortly. Independent of underlying hardware, and it brings networking security closer to the application where it's running. So typical use cases might be zero trust security, multi-cloud networking, network automation, container networking, advanced load balancing, and container ingress. So anything you can do with your F5s and your Fortinets or your checkpoints, you can implement in NSXT as software-defined networking. You get a complete layer 2 to layer 7 networking and security virtualized platform. You can manage the entire network as a single entity from a single pane of glass. Enforce consistent networking and security policies, and automate and tailor the network to your needs. So that term automate is a game changer. You can build and automate the entire network infrastructure as infrastructure as code using Terraform. And that's in fact what we did for this last client. And it was an absolute game changer. Now, there's been some numbers splashed around to say that it can save up to 35% by consolidating your network and security functions into a single platform. Fantastic. And you're saving in a lot of toil as well. You're not logging in constantly and doing all these things. You can have a full CI/CD pipeline to deploy all your networking. Agility through automation, one-click provisioning, and it's all managed by IAC, which we've talked about. One of the things I do like about it is you still do have the ability to go into the web GUI and look at the infrastructure at that point. So you can deploy via IAC, and that works great. But actually in NSX, you get a topology. It gives you a dynamic map of what your topology looks like. And that can be really handy for visualizing things for yourself or explaining things to others that may not be as savvy and they need a bit of a diagram to help them through. A basic design, for instance, in NSXT, you would have a tier 0 router, and the tier 0 router connects up into Google, connects into the VMware API in your project, and then connects by a private service connection across to your Google Cloud services. And then from that tier 0, you would have a bunch of tier 1 routers. Now, hanging off tier 0, you'd probably have tier 1 for production, a tier 1 for non-production, and then maybe a tier 1 for like your management stuff, just depending on how you want to design things, what your corporate security policies are, and how, if you're doing a migration, what your starting situation would affect how you would lay that out. But it's really flexible and really quite easy if you want to make a change later. We had a situation where we wanted to move I'm trying to remember the details here, guys. We wanted to move one network from one tier 1 to another tier 1, and I remember we spun up a new tier 1 because we wanted to change the load balancer provision or the tier 1 provision size.
Yeah, because the tier 1s are provisioned as either a routing tier 1 or a load balancing tier 1 because they're different node types inside of VMware.
That's right. So when we initially spun it up, we did it as a routing tier 1, but later we realized we needed load balancing in that router. So it was just a matter of creating the new router with the load balancing enabled, and then I changed a 2 to a 1 in one line of code, and then ran the thing, and it just flicked it over to the new router. And
it was like 12 network segments just immediately.
12 networks that it just immediately moved, and it would have been instantaneous. When you run the Terraform code, it is so quick what it does. And it just flicked it over instantaneously. So, yeah, massive advantage to having infrastructure as code.
And that was a thing throughout the entire project. Is we needed to add DHCP to one of the networks. It was we go away and do the changes in the background. Takes us 5 minutes. Apply it, and it's done instantaneously.
It's done.
Yep.
Yeah, you can do everything, right? You can do DHCP, which you just mentioned, DNS, north, south, and east, west firewalling, gateways, routing, tagging, load balancers, OSPF segments, BGP. You can do the whole lot, all in one single plane of class. Now, there are a couple of funny things with NSXT. Look, I don't know if this is a function of, I do know it's a function of the NSX, the Terraform provider. Not everything that the API provides is available in the provider. There are some ClickOps things, but we typically found that they were set and forget. You just go in, you ClickOps it, and that's it. You kind of don't need to go and change that again. Certificates, for instance, you would go in and put the certificates in, and then as Terraform ran, it would just read those certificates as data, and they would be available to Terraform.
Yeah, you'd probably still for certs need to build out a parallel certificate automation. I think would be ideal there.
That would be ideal, yeah. If the Terraform provider does ever provide it one day, then that would be what you would need, a separate pipeline to handle that.
All the APIs are there, so if you were either coding something yourself or you've got something else to use, the APIs to be able to manage certificates in NSX are there. It's just the Terraform provider doesn't implement them right now.
I think the one that I found quite odd was we were trying to set up SSL profiles or application profiles, I think it was, inside of the load balancer, and we couldn't do that in Terraform. We had to do that in the GUI. I was like, hang on.
Once they were in, then you could reference them as a data object.
That's right. It was It took 2 minutes to do it, but it was still like, why?
Yeah.
Odd.
98% of everything else we did in the project was done in Terraform.
That's right.
Yeah, that's right. Look, I don't think it's a big deal.
No.
And it does seem like they've focused their effort on the things that are going to be more dynamic. Those kind of things that are ClickOpsy, they're set and forget. You set them up and you don't have to worry about it again.
Yeah.
You just, but in our particular case, we had two sides, and Zone A and Zone B, so we had to be careful that those ClickOpsy things were replicated exactly the same on each side, because obviously when the Terraform ran, we ran it out of a single code base. It needed to see those data sources on both sides that matched. A couple of things I really like about it. Obviously, IOC, like building it as infrastructure as code, unbelievable. Specifically, one of the things was sharing of objects between load balancers and firewalls. So in the past, you might have had to define an object in the firewall and then go and define the same object in the load balancer. They've got the same IP, they're the same thing. Well, why not just have a single file? And this is exactly what we did in Terraform, that defined all your objects. And then when you build a firewall rule or you build a load balancer, it's referring to that host and it knows that IP address. So later on, if that host changes, a different IP, different network, you change it in one place, run your Terraform again, and boom, it just gets, that change gets reflected out everywhere in all your infrastructure. Great having them all integrated like that. Full text searching across your code.
Yeah.
That's like, how cheeky does that feel? Hey?
It was awesome. It really was. Yeah. Like finding firewall rules that needed to be modified or an endpoint that needed to be changed to a different IP address was just so much simpler doing it like that as opposed to trying to bumble through a GUI.
Oh, yeah. Yeah, just bang, just find it. Oh, there it is. Now,
especially when you had to update like a bunch of them. You're like, oh, okay, we've changed the IP range we're going to use for these VIPs. Okay, we've got like 20 things to go update.
Yep.
Done. Terraform apply.
Yep. And on that too, and I don't have that on my list here, but I was thinking there was a particular thing in there. We had to put some names into the segments, and you guys said to me, "Oh, Steve, can you append the third octet of the segment IP to the name?" Okay, well, we can do that programmatically, and sure enough, we've done it programmatically. So you're not going in there and manually typing out all these names, 500 different names. Just does it on the fly for you. Yeah. If the IP address changes, bang, it just renames the name of the segment. And on that, the other big advantage for the devs, for instance, is that the code base can be visible for everyone. So in the past, and I'm thinking of a specific instance here, like the devs may not know which server a particular domain lands on, because they're not seeing the load balancers, they're not seeing the pools, they're not seeing the way that's distributed, or they don't know the load balancing algorithm, for instance. Why not just give them access to the repo, read access to the repo, and they can have a look through there, and they can do their full text search across it and find exactly the information they like.
And then you could also, if they want something changed, they can raise an issue. In there, go, hey, this IP, can we change that?
They can raise a pull request on the repo, right? It's done. Yeah. And it's not sort of all up to a single, network admin to go through and find this constant information. I know when I was doing that kind of job, 99% of the work is just requests for information, right? And, how does this connect to this and how does that connect to that? And, you're going to need a firewall rule for that. Well, now the guys can go and see it themselves.
Self-documenting infrastructure.
That's right. And bringing new network admins up or security admins up on what's in production currently. It's so much simpler doing this. Go and read these files and you'll learn it pretty quick.
Yep.
As opposed to having to step them through a web UI to show them what's happening.
Or 3 or 4 different web UIs.
Yes, that's right, 3 or 4.
Yeah.
Yeah, we got
load balancer, proxies, firewalls, all different boxes. It's just all in one place.
I think we didn't touch on it, but again, because this is managed, like you don't have to worry about like the edge clusters and all the uplinks and all like the underlay network stuff for NSX. don't have to worry about that. Like, that's managed by Google, right? You can live quite happily in the overlay networks. You can build out anything. However, if you do have a need, so for example, if you've got a backup appliance that's going to have a lot of traffic, you might not want to haul all that through NSX. You can get access to the underlay networks and get access to a subnet, put your VM on that for your backup appliance or a replication appliance. Like, you've got all that available to you. But in normal operation, you can quite happily live in NSXT segments.
And to that point, I was talking to one of the Googlers the other day who said that Google are making available, I think he said it was 5 VLANs for customer use on the underlay networks. So Google obviously provisions a whole heap of VLANs for GCVE to work on. They're giving access to customers to 5 different VLANs for use for their backup solutions or whatever other solutions they need to use.
Right. So this is kind of, think of it kind of outside GCVE then?
Well, I mean, it's within GCVE still, but it's outside of NSX.
Yes, outside of NSX, yeah.
Right, right.
It's the underneath of GCVE, so provisioning VLANs directly on their switches as opposed to on your software-defined switches.
Yeah, because if you think that, an ESX host in GCVE is tin and it has network interfaces, and those network interfaces have VLANs that are plugged into switches, like those, it still exists in the real world. It's not a virtual ESX host. You've got tin. So there is, VLANs that can be accessed, and, they do make them available now, which is just really cool. It adds a lot of extra options.
Yeah, right. And one of those things that you can do with those extra VLANs is HCX. Yeah, so tell us what HCX is all about, Dave.
Yeah, cool. So, and as you mentioned, like, HCX is deployed on these underlay networks, right? Because it's really storage. There's a lot of data transfer that will happen with it. So what HCX is it's a VMware product, and it's included in your GCVE license. You actually get HCX Enterprise included at no extra charge. It used to be HCX Advanced, and you could request Enterprise, but it sounds like pretty much everyone requested Enterprise, and so now it's the standard offering. What HCX is used for is it is really the absolute easiest way to migrate a VM from on-prem into the cloud, like, hands down, right? Because you can do it in like a lunch break. With HCX, you use it to stretch your on-prem networks into the cloud. So what you do is you deploy an on-prem appliance. It creates a tunnel to the HCX destination in GCVE. And then once those tunnels are in place, the mesh it calls, you can then say, like, okay, this network, for example, maybe I've got, my data center might have like 20 VLANs, and I want to move a VM from one of them, or 20 of them. You select that VLAN and you extend that out into GCVE, and it will provision a destination network for you in NSXT. So it's not doing it in Terraform. And this was something that we ended up in our project. We would let it build the networks for us, and then we would import them to Terraform, so we could work with them later. But it will build this destination network. And then while the network extension is in place, it has like a proxy appliance that's deployed in the destination end that takes over the gateway. And so once that's there, it's creating a fully encrypted tunnel from your on-prem to GCP, which is absolutely brilliant. And then once that's in place, you can take your VM, or 10 VMs or 100 VMs, and choose from an array of different migration options to send it over to GCVE. And if you use any of the online ones, like, it's the same as a vMotion within your data center. Maybe you lose a ping, maybe you don't even lose that. And then that VM will be running in the cloud. The only thing that you'll notice is, the latency will change slightly if you were pinging from within the data center, and, maybe you've added 2 milliseconds because you're now over at Google side or wherever it is your destination is. But it still works. Your server that's now in GCP can still access all your on-prem stuff. It'll still route back on-prem. It's so flexible, and there's so many different ways that you can use it. But yeah, so stretching your VLAN out, moving the VMs, that's probably the kind of the standard way, right? Yeah.
And that's the best way to think of it, isn't it? It's just a stretched network that now appears in both sites, and then that VM is free to move between the two sites. If you migrate it across and it doesn't work out to plan, you can migrate it back quite easily.
Yeah, definitely. You can do a reverse migration. You can send it back on-prem.
And then when the time comes, you unstretch that network and you change your routing so that network is now routed to within GCP, and all your on-prem stuff can find it. We didn't talk about it before, but that routing is just handled automatically via BGP, and there's a BGP relationship between GCP and your on-prem devices via your however you're linking into GCP. And that's handled automatically as well.
Yeah, that's we didn't touch on it, but that's the really awesome thing, right? Is that you can move those VMs over, and you don't even need to re-IP them, because you're picking up a subnet and you are moving it over to GCP. And I mentioned that you can move one VM. Eventually, you would move like everything that's on that subnet. You would get them all running over in GCVE, and then when they're there, go, okay, cool. We're going to do a network change now, and as Banky said, right, we're going to chop off that VLAN on-prem. We're going to change the routing that exists now purely coming from GCP. Or, maybe you're changing some of your network topology at the same time, right? So it gives you the option of like, okay, we'll build out a couple of new segments, and we are going to re-IP a few things. You can choose how you want to run that. One of the other really cool things is you've got a few different ways of moving the VMs. So included in this, because you do have HCX Enterprise, you can do a bulk migration. Now, I found the bulk migration probably to be the most flexible. It has the lowest requirements. You only need to have VM hardware level 7 to be able to do a bulk migration, that's really old. It's like 10-year-old VM hardware version. And you can queue up to 100 servers. You can basically choose your 100 servers as long as their network extensions happened. You can seed their data across to GCVE, and you can set a maintenance window. So they say, for example, I've got my 100 servers. It's like 20 terabytes worth of data. I'll wait a few days for that to synchronize across, and then I set a date. Say, all right, at 5 p.m. on Friday night, because I don't want to do anything on Friday night. At 5 p.m. on Friday night, the maintenance window for these servers opens up. And at 5 o'clock, it will shut them down on-prem and it'll power them up in GCP. Generally, I found that entire cutover, no matter how many VMs I threw it at, was about 7 minutes. So it's real quick. And it's effectively just a reboot for the VM. There's a 2-hour RPO. So if you, depending on your rate of change, like after it shuts down the server, it kind of syncs that last delta across. But again, it's only 2 hours worth of sync. But that's shutting down a box. You can certainly do online migrations with vMotion. So vMotion will do it one at a time, but you don't have to reboot the server. And then there's also replication assisted vMotion, which is kind of a hybrid of the two. It has the kind of bulk initial data sync that it'll do for all the servers, but when you get to the maintenance window, it will then migrate a server one at a time. So if you're doing a lot of servers, that's probably the quickest. That also has no impact. So it's real slick. And then also, depending on what you want to do, there's a whole bunch of additional options that you can apply as part of the migration. So you might decide that as part of the migration, I also want to upgrade the VM hardware or VM tools, or run a personalization script or update DNS servers. And if you want to do any of those things, you can enable that as part of the migration. And then there's also there's one other way of using HCX, which it has like a whole DR side of things, which you could use post migration. But I think Ian's had the most experience on the DR side. So
yeah, cool. Thank you. So as Dave said, HCX can be used as DR, but there's a whole heap of tools in GCVE that that we can use for DR. Obviously, there's the third-party tools that you're probably already aware of, Zerto and the likes. You can plug them straight into GCVE and off you go, use them exactly the same as you did before. There's also SRM, so VMware's own site recovery manager. That requires a separate license. It's not a licensed product inside of GCVE, but if you've got licenses for it already, go for it. It's a great tool. As Dave mentioned, HCX is a perfect solution. You've got it there already. Why not use it? HCX is included for free. You get the enterprise license. That gives you the ability to replicate your VMs to a different zone or back maybe on-prem if you wanted to use on-prem as a DR site. And as Dave said, it just keeps that replication flow going. So data as it changes in GCVE or on-prem gets replicated to the other site.
And I think you can get down to RPO 5 minutes, I think, with HCX.
Yeah, 5 minutes is the minimum. But the other one that we found, so obviously SRM has got this capability of restoring to a bubble. And that's a fantastic feature. We love it. We think it's awesome. We found a way to do something similar inside of HCX in that your tier 1 that you're restoring to is disconnected from your tier 0, and you do a test restore inside of HCX to that same network, and you have a perfectly running environment inside of that disconnected tier 1. I can already hear people screaming at the microphone. How do you access it then? It's simple. Another tier 1 that's connected, put a leg in there, put a leg into the disconnected tier 1. Now you've got access. Really simple solution. It's a really intuitive user interface, and there is lots and lots of documentation on how to use HCX as a DR solution. Google's got a heap, and VMware, obviously, they have their own documentation. But then we've got Google's own backup and DR solution. So Google bought a product called Actifio Go, probably 12 months ago now, I think. And it is a first-party marketplace backup solution for all GCP resources. So that includes GCVE. For GCVE, it uses VMware's vStorage API for data protection protocol. So not only can it back up GCVE resources, but it can also back up your on-prem resources and be able to restore into GCVE, or vice versa. It's really simple to deploy. If you're deploying it into Compute Engine, it's just a simple click in the marketplace. If you're deploying it into GCVE itself, it's simply getting in contact with your SA and getting the OVA files to deploy, and then it's up and running in. I think we got it up and running for the first time I'd ever touched it in probably 2.5 hours. To deploy the VMs and get them IP'd and everything. Ideally, if you're going to do it in GCVE, put it into one of the underlay networks, so one of the VLANs that Google now gives you access to, because it is pretty storage intensive on the network. And the other trick that we found is if you're going to be backing up large things into a snapshot pool, make your primary snapshot pool the smallest size you possibly can. That's because you can't delete it.
Not easily.
Well, not yes. No. You can delete it.
Not without a service call.
Yeah, it's going to take a bit. So that was a learning curve there, but obviously it's a really good product. Again, it's a first party service. You can use it. So if you're in that modernization piece, you've moved all your workloads into GCVE, and now you're trying to use native services for it. Actifio Go can back up all of those native services, and it just stores all of your long-term snapshots into GCS, so you can store it in nearline or cold line storage, and your snapshots can be stored as either GCE block or GCV vSAN. So that one's a really cool one to look at, and obviously a really cool product from a backup perspective inside of GCVE and Google as a whole.
Yeah, awesome. And I think that's like the fact that they've got Activio Go there. Like it's a common question that we get, right? Like, okay, I'm moving off-prem, and I had all my backup infrastructure here. I have my other data center. Okay, I've probably time to think about a new backup solution.
Yeah. I mean, you can still use your Commvaults and all that sort of stuff.
Sure,
if you really
options.
Want it. They've got options. They've got abilities to back up VMs, but they back up VMs. It's not like they have native access to GCE or Cloud SQL or anything else.
Yeah. So, it's a common thing. Like, okay, we're thinking about the solution. We can keep going with what we've got, but maybe use the cloud version of it, or Activio's there. So,
yeah.
All right. Well, thanks, guys. I think we've covered a lot of topics today. Certainly, it's not. If we were to go into all the minutiae on every subject that we've covered over the last 3 months, we'd probably bore you all to tears.
It'd be a 10-part series.
10-part series. But look, GCVE is just a paradigm shift in the way that you work with VMware, and certainly makes things a lot easier from our perspective.
Yeah, and I think it's a solution that continues to improve. Like even in the time that we've been working on it, new features have become available. Things have changed in the product. Like Google are actively developing this, and we're seeing a load of interest in the market. Like we've wrapped up a project now. We will very soon be straight into another one. There's a lot of interest in this.
And yeah,
absolutely.
To that point, the VLAN stuff wasn't available when we started using it.
Yeah.
So that's available now, and there's plenty of other features that are on the roadmap there that are very shortly to be released.
Mm-hmm.
Yeah, look out for it. There's going to be some big announcements coming. But if you want to find out more about Google Cloud VMware Engine, then you can catch Ian and I. We're giving a talk, Ian.
Yeah.
We are going to be at the what's this thing called? The Solution Series on the 10th of August. The Solution Series at the Sydney Google head office. The 10th of August from 1 p.m. to 5:15 p.m. And I think our talk's around 3 o'clock?
Yeah, something like that.
3:20.
And you're going to be there in person, right? In Meatspace.
We're going to be in Meatspace. That's right.
How cool is that?
Along with a whole bunch of absolutely. And Ian's going to make the trip down from Queensland. We can finally catch up for that beer, and it's going to be great. So come along. Google usually put on a good spread too. There'll be some nibblies and a few drinks there beforehand. Come along and watch us talk all about VMware Engine on Google Cloud. But I think that's about it from us today, guys. Don't forget, people, to go to iTunes and write a review for the show. That will really help the show out. And check out Kasna Between Two Clouds, our sister YouTube channel, where you see our CEO and CTO talking about Google Cloud. I might even convince them to talk about GCVE. You can contact the show, gcplife@kasna.com.au. We've got the Twitter @GCPLife. The website, you can Google that. And don't forget, today's sponsor is Kasna. At Kasna, we make your Google Cloud and GCVE solutions possible. You guys got anything else to add for today?
No, I think you've summed that up.
Yeah.
That's the 20th time I've done that outro, so I have to be getting good at it.
That's gold.
No, that's it for me. I hope everyone has a great weekend.
Yeah, same here. I'm looking forward to catching up next week at Google On Air.
Yeah, well, we'll see you there. And that'll be it for us for 2 weeks. We'll see you later. Bye.
Ciao.
In the middle of Dave talking about bloody HCX, my son walks in from school.
I saw you gesture. You're like, go away. You need one of those red recording lights out of the door.
Yeah, on air.